Hey guys, welcome to the start of a brand new unit. Today we're going to talk about polynomials. That's something you've done in seventh grade. You've added and subtracted polynomials. You've named polynomials. You've combined like terms, that sort of thing. We even did a little bit of combining like terms this year when we solved the equations. But today we're going to take it into a whole nother direction. And it's this idea of multiplying polynomials and then undoing the multiplication at some point. We call that factoring. So we'll explore that within this unit today. We're going to talk about multiplies and polynomials, probably see some things that you may have seen before. We'll just amp up the challenge for you a little bit. Okay? All right. So let's get into this right away. Here we go. The idea of multiplying a polynomial. And we're going to keep it pretty basic today. I'm sure most of you have heard of the distributive property. Okay. Now, when I say we're going to distribute and multiply polynomials, what I mean is this term here, x plus 2, is what we call polynomial. It actually has a specific name called the binomial because it has 1 and 2 terms to it. This 4 is also called a polynomial. It's considered to be a monomial because it's just a singular term. Either way, what we're going to do is we're going to multiply these two polynomials together using what we call the distributive property, which means we take the 4 and we multiply it by each term inside of the parentheses. So 4 times x and then 4 times 2. And I know what you're saying. Most of us say, I already know what the answer to that is. The answer to that is 4x plus 8. And you're absolutely right. Okay, 4 times x is 4x, 4 times 2 is 8. Those two terms are not alike, so they can't be combined. So we're actually done. That's our answer to this. There's nothing more to it than that. Now, let's practice this idea with a couple more challenging ones, some ones that have some more variables with some bigger exponents. Again, what we're going to do won't change. We're still going to want to distribute here. Take that 3x squared, multiply it by 2x to the third. Take that 3x squared, multiply it by 4. Okay. Now, if you wanted to, you could actually show the work for that. It's, 3x squared times 2x to the third. That's the one thing. Plus 3x squared times 4. I mean, you could show the work if you wanted to. I think a lot of us probably will figure that they'll do it in their head. And we'll just have to apply our laws of exponents. So 3x squared times 2x to the third is 3 times 2 is 6, x to the fifth. That's how you would get 6x to the fifth there. 3x squared times 4 is just 12x squared. Okay, 3 times 4 is 12, the x squared. There is no other x, so it's just keep it x squared. Those two things can't be combined because they're not alike. So I just leave it. I've just done it. I've just distributed and nothing else can combine. Okay. Let's move on. A couple more practice ones that you guys can kind of look at. I know now, if you want to pause the video, you can pause the video. Then I'm going to go through them on my own and you can go back and watch them. It's completely up to you, or you can just watch. So I'm going to distribute. Let's do this part first. 3y squared times 8y cubed. Well, 3 times 8 is 24. Y to the 2 plus 3 is 5. So 24y to the fifth. Then 3y squared times negative 4. So that's going to give me negative 12. That's the 3 times negative 4 part. And just y squared. There's no other y, so done. Complete. All right, next one. Negative 4 times 2 is negative 8. X to the third times x squared is x to the fifth again. Now I get to distribute to the negative 6. So negative 4 times negative 6 is positive 24. Now this is x to the third and x to the first. So that's going to give me x to the fourth. And then one more distributing. Oh, see, this is fun because you get to do 3 of them. Negative 4 times 3 is negative 12. There is no other x, so I just leave it as x to the third. And I'm done. Again, there's no like terms there because none of them have the same exponent. All right, last one. It's got a little bit of a challenge because there's a fraction involved, but it's not too bad. All right, so 2/3 times 9. I think of it as 9 times 2 divided by 3. 9 times 2 is 18, divided by 3 is 6. X squared times x to the third is x to the fifth. You add your exponents. Okay, 2/3 times -6. Again, I'm going to think of it as 2 times -6 and then divide it by 3. 2 times -6 is -12, divided by 3 is -4. X squared times x squared is x to the fourth. 2 plus 2 is 4. And then finally, 2/3 times 3 is 2. And then I have x squared and x to the first, which is going to give me x to the third. Done. All right, so it's just a matter of being able to distribute, okay, and taking one term at a time. Yep, there's going to be some variables with some exponents and things, but we worked on that earlier this year, so shouldn't be too crazy. Now, just when you thought we were done, I have to show you one more, okay? This last one, it says it's a challenge, but the challenge of it is that there's two variables, okay? Just handle them separately. That's all. I mean, we're still distributing. You just got to be able to handle the fact that there's two variables. That's all. So for this first one, when I distribute, I end up with -8 x to the 7th y to the 4th. Okay, the -8 comes from 2 times -4. The x to the 7th is x to the 5th times x squared. You add them. My y to the 4th comes from y to the 1st times y to the 3rd. All right, now for the next term, I get plus 6x to the 6th and y. Okay, my 6 comes from 2 times 3. My x to the 5th and my x to the 1st gives me x to the 6th. There is no other y, so I just bring the y over. Okay, then we distribute to the last one. You're going to end up with -4. That's where the 2 times -2 comes from. X to the 5th, there's no partner for the x. Y to the 5th. Okay, y to the 4th and y to the 1st there. Y to the 5th. There you have it. So even when there's two variables, not really that big of a challenge. Just deal with them separately. That's all. All right, that's it for today. That's multiplying polynomials using the distributive property.